Friends, welcome to lecture 64 of Advanced Steel Design course. In this lecture, we are going to learn a design example of analysis of an offshore topside under impact loads. It's a thorough design example where the excerpts of the design is being projected and discussed for you. So, in this example, we are going to discuss the analysis comparison between steel and functionally graded materials. Okay. Now, we all know that impact loads happen on offshore structures or buildings due to fall of objects. So, they affect the strength of the member. They also challenge the structural integrity. Now, impact loads can occur during construction or operations. Falling of objects from a considerable height may damage the structural components. It can also cause excessive deformation to the deck. Okay. So, the impact loads generally arise from fall of crane hooks itself, fall of objects dropped from a height, machinery components, equipments and tools. Okay. Let us take a classical example of an offshore platform where the top side is being shown on the figure. So, this is a top side element. On this top side, the vulnerable region for impact loads is being marked. This is a vulnerable region. Okay. Let us have a model of this type. So, friends, severe impact loads can be caused on decks of the platform. It can damage the stiffeners, the secondary beams, and it can also result collapse of the deck due to excessive deformation. Therefore, it is necessary to investigate the strength capabilities of the topside elements to support this kind of impact loads. Interestingly, friends, if you look at the accident statistics of offshore units developed by Britain, for the past 20 years period, you can see the maximum accidents because of drop objects have also caused fatalities, and there are increased number of accidents because of crane hooks and falling objects compared to explosion, collision and fire. See this table, and this has been a consistent mark over the years. Okay. So, drop objects, impact loads due to cranes are more frequent, which create accident statistics in at least offshore platforms as per the table shown on the screen. Now, the varieties of cranes being used in offshore structures are shown on the screen. So, the fall of crane hooks of this heavy mass and other objects is frequent, and fall of crane hooks can cause potential damage to structure and people on board. Okay. Look at the typical crane hooks being shown on the screen. They are very massive and they vary from 2 to about 32 tons. That is the range of weight these crane hooks have. Let us pick up a specific crane hook of that order and make a model. Let us say the crane operational height ranges from 15 to 25 meters. So, let us take a 20-meter drop of the crane hook falling freely with a high velocity. Okay. Typical time history of an impact force is what you see on the screen here, which has got a very shorter duration. You can see it is only about 0.07 seconds, but a very large amplitude. Okay. Very large amplitude, about 50 tons, etc. Okay. So, let us say this kind of a model is being applied for this. When you talk about materials which is being used for the topside in the design, material selection plays a very crucial role. Particularly under impact load. During high velocity impact, the rate of strain increases rapidly. Over a short duration of time. This can cause a permanent deformation of member. So, the material chosen should be strong enough, should have higher toughness, higher resistance to impact loads, should possess high weldability and durability. Okay. For comparison, we have taken 3 materials. We have taken steel, which is X52 steel, which is a structural steel commonly used for offshore topside, is also the marine grade steel. Okay. We have also tested with composite and FGM for comparing the performance of this topside deck. When you talk about composites and their use in offshore structures, composite plates are actually fabricated by hydraulic press. So, they have a very serious problem of delamination under high pressure and temperature. So, new materials are being tested. We have also examined FGM. In earlier lectures of this particular course, you would know the combinations of functionally graded material and their characteristics, which has been discussed very well in the earlier part of the lectures. Please refer them back, and we have considered a specific FGM for this application for the time being. Okay. So, for our convenience, let us quickly recollect that FGM offers improved residual stress distribution, it has enhanced mechanical properties, it has got higher resistance to fracture, and it has got reduced stress intensity factors. Okay. So, we are not discussing about the FGM properties at this moment. We will start directly going to the model of the crane hook. The model of the crane hook is showing on the screen, whose dimensions are given here. Okay. The velocity of the impactor considered in the analysis is calculated for 20-meter fall, okay, and the weight of the hook is taken as 2.85 tons, which is subjected to the CG of this hook. The analysis carried out in abacus, and the boundary conditions for the deck and crane hook model are explained on the figure shown on the screen. The crane hook can have a rebound effect only on one direction, as you see here, remaining all are restrained. Okay. So, the deformation contour for all the three materials have been shown here. FGM has the stress concentration only on a smaller area compared to X52 and aluminum. Okay. Of course, this is for T 0.02 seconds, T 0.04 seconds, and this is for 0.06 seconds. Over the rate of time increase, of course, the impact spreads, but even at a higher period, you will see that the stress concentration is far lesser in terms of its area of spread compared to that of X52 and aluminum under this impact load. Now, the response of the deck is also plotted for contact force history, deflection time history, central deflection, and comparison of plastic strain time history, kinetic energy time history, and impactor displacement. In all the cases, you would very well see that FGM material performs better compared to its competitor X52. Okay. If you look at the central deflection of the deck, which is made of FGM, it is showing far lesser values compared to the other two materials taken for the study. Even the deflection time history is lesser for FGM, whereas the contact force time history is much higher for FGM. Okay? So, it has got a very good capacity of plastic strain absorption, as you see here. Having said this, we can now summarize that FGM possesses reduced plastic strain, it also has increased kinetic energy compared to X52 steel. However, if you look at aluminum, it experiences lesser kinetic energy but undergoes excessive deformation, hence cannot be advised for a topshore deck. X52 steel anyway performs better, followed by FGM. So, FGM is far better than all the three compared materials. So, FGM has improved impact strength, reduced plastic strain, reduced deflection for the same thickness of the deck plate. That is very important. So, there is no change in the geometric dimension of the member, only the material is being changed. So, friends, a simple analysis example applied for impact loads explain how the impact analysis can be carried out using abacus by incorporating the material characteristics of FGM and steel, which are discussed in length in the previous lectures. So, friends, there are many references available for this particular course, including textbooks authored by me and other leading academicians of the world. Please go through them, try to learn and create more interest towards the advanced steel design procedures, which has been discussed extensively in this course. Thank you very much and have a good day.